Good morning, everyone. Today we're going to be going over the review. I sent out a review for the final exam, and I said it's part one of two parts, so I'll explain what I mean by the other parts of the review. But just to confirm, our final exam is next Wednesday. It will be at 9 a.m. It'll go till 11:45 a.m. And we do not have class on Monday. So this is officially our last meeting before the test. So make sure you're here next Wednesday at 9 a.m. for the test. Camera set up and everything the way we've done it in the past, and expect to be here for almost 3 hours. So it's gonna be a long day. Any questions about that? No? All right, so did you have an opportunity to look at this review? Did y'all look at it? Did it look like it was familiar? What do y'all want me to do today? Do y'all want me to go through this review? Well, how would you like to do this? Are there specific questions you want to ask about the review, or do you just want me to like kind of work through the problems one at a time? How would you like to do this?
Can you just work through the problems one?
Okay. Yeah. I can see how much I can get done. Hopefully I can get through the whole thing. So before I start this, let me just say that, you know, this review, it's just an old final. This is an old final that I had laying around. So it just gives you some idea of the things that I've asked on final exams before in this class. The second part to this, what I think you need to do is you need to go back and review exam 3, right? The exam we just took. Make sure you go through that exam and understand the things that you got wrong, how to do these things. And I would just go back and review all of your exams. I mean, that's the way you should study for any final exam that's going to be comprehensive. Just go back, go over the exams, go over anything you missed, make sure you understand how to do the problems that you missed, right? So the second exam, this was a lot of sketching, and I think the class did okay on this exam, so just make sure you understand how to do all of this. And then on the first exam, I think y'all did a lot better on the first exam than the others. Again, just go back through this, look at the problems that caused you problems, caused you issues. And just be prepared for anything from any of those previous exams to be on the final. Of course, the final will not be, I won't cover every single thing, right? It's just the test is, we don't have enough time to give you a test over every single concept. So I've got to pick and choose which things I want to put on the final. That's why I gave you an example of a past final, just to kind of give you an idea of what I chose. But I would say anything off of the first 3 exams is fair game. So that's what I would be studying to prepare. Any questions? Okay, let's get to this. So the first question here is, I give you a graph of a function, and you have to determine all of these different things about the function. So first, what's the domain of the function? So I'm going to work through this kind of quickly, kind of think, you know, the thought is that you already kind of know what to do here, or as soon as I remind you, you're like, oh yeah, yeah. So I'm not going to be doing this as if I'm teaching it like from the beginning. Also, you will be allowed on the exam to have a reference sheet. So you can create a sheet with a single 8.5 by 11 sheet of paper, front and back. You can put any formulas, steps, or procedures on that. It must be turned in with the final. All right. So with your work, you must turn in that sheet. So as you go through and review your old exams, I'd be writing down the things you think you need to know. Like, well, we'll see here. Number 2, I believe, is the difference quotient, right? So you need to know the difference quotient formula. I actually did not provide it on this final. So you need to know that. You need to know what it is. So All right, let's do this. The domain of this function. So I'm trying, when I'm looking at the domain, I'm looking, does this function go to the left and to the right forever? The arrow here on the left implies that this function continues to go this direction. Now, on the right-hand side, we have a point where it looks like that's where the function stops. So if it had an arrow, that would imply that it keeps going to the right, but because it has a dot there, it stops at 7. So my domain are all the x values where the function is defined. So it's to the left forever, all the way to 7, including the 0.7. So I put a bracket. Now, y'all just stop me if you have a question, okay? Because I really am going to try and get through this whole thing today. Okay, what is the range? Well, the range, what we're doing is we're looking, instead of the x values, we're looking at the y values up and down, trying to figure out, how low does this function go? How high does it go? And I can see here again, because this arrow implies it goes up, I should go up forever to infinity on the y-axis. But as far as going down, it stops here at -2. I never go below -2. So my range is from -2, including -2, all the way to infinity. So the way I write the range is from the bottom of the y-axis up, is the way I write it. I start at the bottom and I go up. All right, where is f increasing? All right, so that's a different question. F is increasing whenever the function is going up, as you move from left to right. So when I'm in this region right here in yellow, that's where my function, if I were moving from left to right, this is where I'd be going up. And that's happening between 1 and 5. Okay, so I'm going to put here for increasing from 1 to 5. And I told you in class, when you do increasing and decreasing, just always put in parentheses. It's not incorrect to not have brackets there. So between 1 and 5, my function is going up. Decreasing would be anywhere the function is going down, which is all here and all in here. Okay, so again, as you move from left to right, we're going down there. And this keeps going like that, right? So I'm always coming down like this. So that's going to happen from -infinity all the way till I get to -1. And then also from 5 to 7, I'm going down. So I'm going to write that in set notation, or interval notation, I'm sorry, from -infinity to -1. Union, and then now from 5 to 7. There we go. Now, where's the function constant? That's where it would be flat, right? And you can see that it's flat right in this little region right here in blue. And that's between -1 and +1. So I'm going to put -1 to +1, and I'm done. Questions?
I have a question.
Yep.
What would we do if the graph didn't have a constant? Would we just not get that question in general, or would we have to write something different?
If I asked you where it was constant and it was never constant, you would put the empty set.
Oh, okay.
I probably wouldn't ask you that, but technically you're telling, the empty set is basically telling me that it's constant nowhere, right? There's nowhere where it's constant.
Okay, thank you.
Mm-hmm. Okay, what are the local maximums if they exist? So now what I'm trying to do is I'm trying to figure out if there's any points on this graph that, oops, I forgot I wrote on this graph is not static. Let me do something real quick. Let me do this. Okay, so I'm trying to figure out any local maximums. So I'm looking for highest points locally, which means it doesn't have to be the highest point on the whole graph, It just has to be the highest point in that little area. And I can see I have one local maximum right here in red. That's the highest point in that little region. It's like the king of the hill, right? So the maximum, it looks like the maximum, local maximum value is 3. And it happens when you plug 5 into the function. So the way that I would prefer you write this is to write it as if possible, to write it as a point. So I can write as the point 5, 3. Okay, that's a point. All right, if you want it, I would not count it wrong if you just said 3 is the answer, because you're telling me what the local maximum value is, how high it is. Okay, both of those would be fine. You could even do this. If you want to write f of 5 equals 3, that again tells me where it happens and what the value is. Any of those are fine with me. Now, local minimums is a little bit different. You're trying to find the lowest point on the graph in that little region. And there's actually, this is tricky because down here where it's constant, that's kind of like, those are lowest points on the graph. And they all have a value of -2. But it happens at a bunch of places. So it's hard for me to tell you exactly one place it happens. So I'm just going to put local minimum of -2. And there's another local minimum over here at this right endpoint. Because that point is at the end of the graph, it is the lowest point in that little neighborhood. So that I could write as f of 7 equals 0. Or you could just put 0 because that's the actual lowest y value in that neighborhood. Questions there? All right. What is the absolute maximum? So, yeah, the absolute maximum. So what is the highest point on the graph? There is no highest point on the graph. All right, because this arrow goes up forever. So you have no highest point. So you could just say none, all right? Now, absolute minimum would be the lowest point on the graph or the lowest y value out, and that is down here where it's constant. The lowest, the smallest y value you would ever get is -2. All right, moving along, x-intercepts. I have 1, 2, 3 x-intercepts. So they are at -3, 3, and 7. I have a y-intercept here of -2. That's where it hits the y-axis. Okay. Where is the function positive? Not increasing, but positive. So that's asking where is the function above the x-axis? Okay, that when a function is positive, it's above the x-axis. So my graph is above the x-axis here and here. That's where it's positive. And it's negative here in this region. So I have to do this just like we did up here with domain and increasing and decreasing. I have to give the x values where it's above the x-axis. So I'm going to put -infinity to -3, union 3 to 7. That's where it's positive, right? From -3 to the left and from 3 to 7. And it's negative between -3 and 3. Now here I did not put brackets, and that was on purpose because if you include the endpoint, like let's say that I included this, right? Let's say I put a bracket here. Then what you're telling me is that at 7, your function's positive. But at 7, your function is 0, isn't it? Because it's actually on the x-axis, and 0 is not a positive number. So it's not, this is not one of those things where you get to choose. You have to put a parenthesis on this for positive and negative. Questions there? Okay, 1 down, 13 to go. All right, find and simplify the difference quotient for this. So you need to know what the difference quotient is. This is the difference quotient. You'll see a lot more of this in Calculus 1. That I would have on my reference sheet. That's the difference quotient, DQ, I'll call it DQ, difference quotient. And if you go back and, like I said, review the old exams, on exam 1, on exam 1 right here, problems 12. Is this exam 1 review? Yeah, this is the review for exam 1. So on the exam 1 review, I gave you 3 functions and asked you to find the difference quotient. And I reminded you what the formula was here. So again, good to go back and review those old exams. You know, one thing you can do that might be useful, if I don't know if any of you plan on trying to create like a study group that you can meet. I know this weekend is Mother's Day, it's gonna be kind of hard, but one thing you could do is have your old exams and just have someone, your friend or family member or something, just pick a problem and off the exams and give it to you and just see if you can do it without anything but your reference sheet, you know? Like practice the testing environment as much as you can. All right, let's go. I'm gonna try and do this difference quotient. So I need to figure out, first of all, what's f of x plus h. So what that means is I'm gonna take this function and I'm gonna plug in x plus h. So I'm gonna just do this on the side before I actually do the difference quotient. I'm gonna figure out what that yellow part is. So I need to take this expression and replace the x with x plus h. So all I did there is replace that x with x plus h. That's what the top left corner of this is going to be. Now I also need to know what f of x is, but that is easy because that's given to me. That's the original function. And then I'm going to divide the whole thing by h. So this is just kind of scratch work to kind of get myself ready for the difference quotient. So I'm going to take 5 over x plus h minus 4, subtract from it f of x, which is 5 over x minus 4, and divide the whole thing by h. All right, so that is the difference quotient set up, but you're supposed to simplify it. And if you remember when we did this, I said if you do the difference quotient properly, you should always be able to cancel the h out of the bottom. This h on the bottom should cancel somehow. So what I'm going to do here, because I see these two fractions, I'm going to get a common denominator. So I'm going to multiply top and bottom here by x minus 4, and this top and bottom here by x plus h minus 4, x plus h minus 4. So what that does is it allows me to multiply this through, allows me to multiply this through, and on the bottom, I'll have the common denominator, or they both have the same denominators. I'm not going to multiply out the denominators up. So when I multiply the 5 through on the left, I get 5x minus 20 over the common denominator minus, now I distribute the 5 through the top there, so 5x plus 5h minus 20 over the common denominator. All of this divided by h. And since they now have the same denominator, I can put these two together, but this is a subtraction. So the subtraction is going to have to pass through to each of those terms. So my next line should look like this: 5x minus 20 minus 5x minus 5h plus 20 all over the common denominator. All of that still over h. And if you do this right, like I said, good things are going to happen. I'm getting my 5x's to cancel. I'm getting my 20s to cancel. And so all I'm left with on top is a negative 5h over my common denominator all over h. Now, the h is going to cancel, but I just want to illustrate again why it cancels. This is like h over 1, and so you have a fraction over a fraction. So you can really think of that as multiplication of the reciprocal. So you can multiply this by the reciprocal of that. So put 1 over h over here, okay? And then it's a little easier to see that these h's will indeed cancel. And so your final result is you have a negative 5 on top you have on the bottom x minus 4, the common denominator, x plus h minus 4, box it up. That's your end result. Questions? If you go back again and look at that exam 1 review, I gave you 3 different kinds of difference quotients. So again, as you're reviewing for the test, don't be like, oh, he's going to give me a thing with a fraction in it. I may not. I might give you something with a square root in it, right? And if you do the square root, we had to do the conjugate. Like, you need to go back and look at these things because there's various different types of different quotient situations you run into. All right. So don't just look at the review as being, oh, you know, it's going to be just like this. It's more of like a concept that you need to understand. So you need to understand difference quotient and all the different algebra that can come with it. All right, find the domain of this function. So this has to do with whether or not you can solve a quadratic inequality. The whole idea here is that we have a square root. So when you have a square root, you cannot have a negative underneath it, right? You're not allowed to plug a negative into a square root, which means that you have to promise me that x squared minus 3x plus 10, that must be greater than or equal to 0, right? It cannot be negative. This is a quadratic inequality. And we studied how to solve these. There was a procedure for this. The first step for solving quadratic inequality is to make it an equation first. So you turn it into an equal sign and you solve this. All right, now this quadratic, it doesn't factor, no? That doesn't factor? The only thing it multiplies to be 10, right? Can we make this problem a little easier for us so we don't have to do quadratic formula and waste time? Can I make this a minus 10? Make this a minus 10 here. Because if I make it a minus 10, that should factor now, right? X minus 5, x plus 2, right? That factors better. If I had left that as a plus, you would have to use a quadratic formula and you would get your 2 solutions, all right? But to save us time, let's just do this. We get 2 solutions, 5 and negative 2. Okay, this is not the end of the story here. Okay, this is the first step for solving a quadratic inequality. The second step would be to draw a number line, put these 2 solutions on the number line in proper order. That breaks up our number line into 3 regions. And what we need to do is pick test points in each of these regions and test them into the original inequality and see if it's true or false, or into this to see if it's true or false. So let me pick a number over here, negative 3. 0 is between negative 2 and 5, and then something like 6. So let's try plugging in negative 3 into this and see if it's true, right? So I'm taking this and I'm testing. Negative 3 squared minus 3 times negative 3 minus 10. Is that greater or equal to 0? This is a question. So let's see, that's not, is that 9? Yeah, 9. And then plus 9, and then minus 10. And is that greater or equal to 0? Yeah, because that's 18 minus 10, that's 8. 8 is bigger than 0. This is true. Which means that everything over here works. Check, everything in that region works. If you plug in 0, it doesn't work. And if you plug in 6, it does. I'm not going to show the work. So that means that I need to represent my answers, everything in this region forever to the left and everything in this region forever to the right. So it'll look like this. My answer, the domain of this is negative infinity until I get to negative 2. Do I include negative 2 or not? At negative 2, this quadratic is equal to 0, right? And in the inequality, we said we needed to be greater than or equal to 0, right? So we do want to include -2. So I put a bracket. And then union, now I want everything from 5 to the right forever. And again, I want to include 5 because when I plug 5 in, I get 0, which I'm allowed to have. Any questions here? Let me just show you, had I changed this problem, okay? Let's say that I had given you this instead. 1 over the square root of x squared minus 3x minus 10. What if I had given you this instead and asked you for the domain? Well, we still have the fact that this here can't be negative, right? Underneath cannot be negative because we're doing a square root, but it also can't be 0. This time it can't be 0 because if the denominator is 0, we have division by 0. So the way that would change the problem is that we would do the same setup. We would do the quadratic equal to 0. We would do all this, but we would not want to include these points because if we plug in -2 or 5, we get 0 in the quadratic and division by 0 is not allowed. So basically the answer here would be -infinity to -2 parenthesis union parenthesis 5 to infinity. See, we don't want those endpoints in there that time. See the difference between those? No? Okay. All right, what's next? Graphing a quadratic. So there was a set of steps for this, right? So this is looking like exam 2 stuff, right? Sketch using the methods from class, right? This first one is a quadratic, so that's what we want to do here. Where'd it go? There we go. Let me see what the next one is. We have sketching a polynomial next. Okay, didn't ask you to sketch, we didn't put a rational function in here. Okay. All right, so y'all want to go through this? Go through all the steps? Yeah, let's do it. All right, first thing I'm going to do is, well, what are the steps? First thing we want to do for a quadratic, right? You have to know this is a quadratic, right? Because there are a certain set of steps for graphing a quadratic function. Those steps you should probably have written down, right? That's something you would probably want to have when you do the test. You see, did I have a review? No, let's see. Yeah, step 1, okay, up or down, vertex, quick sketch, x-intercepts, y-intercept, sketch it. Okay, so that's basically what I'm going to do here. So the first step is to determine if it opens up or down. This parabola opens up because a is 2. And if a is positive, then we open up. Step 2 is to find the vertex. To find the vertex, we need to find HK. H, there's a formula for it. It's -b over 2a. And so for us in this problem, a was 2, right? +4 is our b. -11 is our c. So I need to do -b over 2 times a. So that's -4 over 2 times 2. And that just gives me -1. That's a very nice h. And now to get k, what we do is we plug that answer, -1, back into the function everywhere we see x. So when I plug that in, I get 2 + 4 is 6, take away 11, -5. So my vertex is the point -1, -5. The third step is was a quick sketch. So what we're going to do is we're going to figure out how many x-intercepts we have. We doing good? Or wait, why didn't I, wait a minute, hold on. It was -1. Why didn't I put a negative in there? That's wrong. -1, -1, I apologize. This was supposed to be 2, and then this is a -4, -4, and then -11. That should give me -13. Are we on board now? Sorry about that. Our vertex is -1, -13. I would have figured that out at some point, but I messed that up, but I'm glad I caught it there. So the quick sketch is all this is designed to do is to help us figure out how many x-intercepts we have. So I know that my vertex goes to left 1 and down 13. My vertex is down here somewhere, and my parabola opens up. And since it opens up, I know I'm going to have 2 x-intercepts. So I've got to go find them now. That would be the 4th step, is to find the x-intercepts. And to do that, we have to take the quadratic and we have to set it equal to 0. And I don't know, does this factor? Has anyone tried it? I need 2 numbers that multiply to be -22 and add up to be 4. I don't think it's happening. No, right? So you're going to have to use a quadratic formula. So let's see. I'm going to cheat. I'm going to just solve it. I don't want to go through and have to do the quadratic formula just for time's sake. Let's see. My calculator is getting 2 solutions here. So I'm going to use a quadratic formula for this. And the quadratic formula spits out -3.55. I'm just going to round 2 decimal places. And then I have a positive answer of 1.55. Okay, so I'm not showing that work, but you understand what I'm doing, right? Make sure you have the quadratic formula written on your sheet if you don't have it memorized. And now the y-intercept. Okay, the y-intercept is whatever you get when you plug 0 into the function. And that's just going to be that c. Whatever c is the y-intercept, so -11. And that's it. That should be all we need to graph this. So I'm going to do my vertex -1, -13. Oops, I didn't give enough room here, but -13 is down here. I'll label it -1, -13. And then an x-intercept, -3.55 and 1.55. So -3.55 somewhere around here. -3.55, 0, and then 1.55, 0. And then a y-intercept of -11 was here. And then I'm just going to draw a U, but it needs to be symmetric. Like, you don't need this dotted line, but just remember this imaginary dotted line should be, the parabola should be like a reflection of itself over that line. So, oops, I missed it. And then this way it should look kind of the same. There we go. All right, what do y'all think about that? Does that again ring a bell? Is this good with me continuing like this? Is this what y'all want me to do? I'm trying to utilize our time the way that you think it would benefit you. Yeah. If at any point you feel like you don't need to see all this, I'm not forcing you to be here. Like, there's no new material today. So if you feel like, hey, I can go do this on my own, you're free to go. I'm not going to hold you down here. I would advise you to stay, but okay. So sketch this polynomial. So again, you have to know, right? You need to know that we're looking at a polynomial function now. It's not quadratic. So there are a set of steps for this as well. The first thing that we do with this is the leading coefficient test. This is where you identify the degree of the polynomial. You identify the leading coefficient of the polynomial. So the degree is the highest power of x, right? The highest power of x that I see is 5, and that's an odd number. And then the leading coefficient is the number in front of that, which is a 1, and that is a positive number. And then you have to go to that chart. Remember that chart that I had that showed, like, you know, up, up, down, down. Remember all that? You have to go have that. I would have that chart on my reference sheet unless you've got it memorized. But this would mean that the left side goes down and the right side goes up. Okay, off the chart. So I know that's the general behavior. I just need to know what's going on in the middle. So to figure out what's going on in the middle, I'm going to find the x-intercepts and also the multiplicity, which is what helped us figure out if something bounced or crossed, right? So I'm going to set this equal to 0. And I'm going to try and factor this so I can pull out an x squared. Be extremely careful here. I'm pulling out an x squared. I'm left with x cubed minus 13x plus 12 equals 0. Please see that what is in the parentheses is not a quadratic, right? This is not a quadratic, but I still need to factor it. So what do? Drum roll. What else did we learn in here? How do you factor something if you can't factor it the way you normally learned how to factor?
Was this synthetic division?
Synthetic division. Yep. We're going to do that whole thing where we make a list of numbers, and it's going to, okay, that's life. Okay. It's college algebra, STEM, right? That's what we have to do. So, all right, what I'm going to do is I'm going to see if you remember how to do this. I'm going to look at the number in front, the number in the back, positive 12. I'm going to create first a list out of all the numbers of 12, all the factors of 12. So positive and negative 1, positive and negative 12, positive negative 2, and 6, and then 3 and 4. And those are the only factors. And then I have to take the number in front, which are all the factors of 1, but this was just plus or minus 1. And this was that special case where I said, if the first number is a 1, then you can ignore it. And this is basically your final list. Okay. If this was like the number 2 or something, you would have 1 and 2, and then you have to create all those fractions out of the list. Again, go back and look at how we did synthetic division. So now what I'll do is I'm going to try all these numbers in synthetic division, but I have to get my synthetic division box set up properly, which means I need the correct numbers in the box, and the numbers come off of this polynomial, but notice we're missing an x squared term. So this is going to be 1, 0, negative 13, and 12. If you mess this up and put 1, negative 13, 12, it's over at that point, right? You've got to have a 0 for the missing x squared term. And then I'm going to start with 1, and I'm going to try my synthetic division. So if I do 1, it's 1 comes down, 1 times 1 is 1, 1 comes down, 1 times 1 is 1. And I get negative 12 when I add down. Oh my gosh, it worked on the very first try. Look at that. That was nice of whoever made this problem to make it work on the first try. Now, what does that tell me? This is the real important thing. What do you say from this? From here, that tells you that x minus 1 is a factor. And then the other 3 numbers give you the remaining polynomial, which will be a quadratic, because the power that you start with here is always 1 less than the power you started with when you did the synthetic division. And we're not even talking about the x squared. The x squared's factored out. We're ignoring that right now. And then once we're here, well, Okay, now I'm happy because that is a quadratic and that does factor. What was left here is factorable. Wonderful. So now I can come back up here where I was stuck. I can say this is x squared, and then everything in parentheses turned into x minus 1, x plus 4, x minus 3, right, equals 0. And now I set each of those factors equal to 0. So when I set that to 0, I get 0. Set that to 0, I get 1. Set that to 0, I get -4. Set that to 0, I get 3. So I have 4 x-intercepts, right? These are 4 x-intercepts. I now need to determine the multiplicity, which is whether or not I'm going to bounce or cross at these points. And to determine that, you have to go back and look at the powers on the factors. The powers on the factors. So I have a 2 as a power on this factor, a 1, and a 1. So if it's an even number, you will bounce. So I'm going to bounce off 0. If it's an odd number, which all 3 of these are, we're going to cross. And that's it. That's all I need. I can draw the graph. So I start out by putting my x-intercepts. Let me see. I have an x-intercept at 0. I have an x-intercept at 1. I have an x-intercept at 3. And I have an x-intercept way over here at -4. I know that the left side goes down and right side goes up. So I know the left side over here goes down while the right side goes up. And I know when I draw this, I'm going to cross through at -4. I'm going to bounce off 0. I'm going to cross through at 1 and cross through at 3. So here, 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 here. And I told you that people may have different versions of this. Like someone might draw something where it goes higher here and bounces and goes higher and then comes here and goes lower and like that. That would also be correct, right? We're going to have different variations in our graphs, but we should all have the same x-intercepts. We should all bounce and cross the same way, and we should all have left and right hand behavior should be the same. Okay. I'm curious, on the second exam, did I give you one? What? Yeah, see, on the second exam, was this the same problem? I was close to the same problem, right? Y'all see that, right? That's really close. So you had to do some, this is actually your second exam. So on the second exam, you did have a problem, almost the same problem, right? You had to do synthetic division on this, but it was -1 that worked, not +1. So it was slightly different. You had a different x-intercept. So this, again, I'm not deviating far from what I've already asked you, again, what I've asked you to do already. You just need to be ready for it, right? Any questions? We're good? All right, what's next? That was a polynomial. I'm actually surprised that I don't have a rational function here for you to sketch. I'm surprised. It is on your exam too. There is a rational function here, right? This was a rational function that I asked you to graph. There's a whole other set of steps. Remember, I mean, this is a really long, tedious process. I will say this, if I give you a rational function, if I do, it will be a very basic one. In other words, you won't have to do synthetic division in it. It will be more like just so like you can explain or show to me, you know, the basic idea of how to find vertical asymptotes, how to find horizontal asymptotes, that you'll, you know, you understand that concept. All right, solve the inequality. Give me just a minute. I'll be right back. I gotta take care of something. y'all can think about how to go about number 6. I had to get something to eat. All right, so how do we solve an inequality like that? It's kind of messy. Remember? Bring everything over to one side. Okay, bring everything to one side. And I don't mean cross multiply, I mean subtract. So x plus 3 over x minus x over x minus 2 less than or equal to 0. And that's the first thing I'm going to do. The next thing I'm going to do is I'm going to get a common denominator between the two things on the left, which means I need to multiply this first fraction by x minus 2 on the top and bottom. And then this one I have to multiply by x on the top and bottom. When I distribute here or FOIL this out, I should get x squared plus x. Wait, hold on, let me do that a little bit slower. You get x squared plus 3x minus 2x, so plus x, and then minus 6 over the common denominator, x minus 2 times x minus 2 times x, and then minus, multiply the top there, you get x squared over x minus 2 times x again. We need this to be less than or equal to 0. Now let's combine those two together. So I'll have the same denominator. And do y'all see that the x squareds will cancel, right? Because this is a minus x squared, it'll kill off that x squared. So all you're left with there on top is x minus 6, less than or equal to 0. This is probably why I didn't ask on the final to sketch a rational function, because you basically have to know what this looks like. Like you need to know what this on the left side looks like, and that is a rational function. So what I'm going to do is I'm going to think about, first of all, what are the x-intercepts of this, right? So if I look at this and I say, okay, what are the x-intercepts? I set the top to 0 and I get x is 6. So I know that if I were to graph this, if I were to graph the left side of this as a function, I know that at 6 I have an x-intercept. And then I have two vertical asymptotes. I have an asymptote at 2. And I have another asymptote at 0. So when I set both of those equal to 0, I get 2 verticals. So I'm going to put a vertical here like that. Okay. So what we're trying to figure out, what this question is basically asking you is, where is the graph of this, right? Where's the graph of this in yellow below or equal to 0? So what you have to do now are pick test points. You got to pick a point here, 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 and here, and plug those in and see if it's true or false. So test points like -1, 1, let's go with 3, and let's go with 7. And those are going to get tested into this, into the x minus 6 over x minus 2 times x. Let's see if it's less than or equal to 0. That's the question. So if I plug in -1 into this, right? If I plug -1 into this, I'll get a negative on top, right? -7. Then I'll get -3 times -1 That would be a positive on the bottom. So I have a negative on top and a positive on the bottom, which is negative. So that means it will work over here. I am below the x-axis over here. If I plug in 1, I get a negative on top, and I get a negative on the bottom, which is positive. Are y'all okay with me just like verbally saying what's going on here? I mean, I don't want to actually have to plug these in. I'm seeing thumbs up. Okay. So it doesn't work when I plug in 1. If I plug in 3, I get a negative on top, positive, positive. Ooh, wait, it doesn't work, does it? No, does it? Hold on. If I plug in 3, I get a negative on top. And then I get 3, I get positive, and I get positive and positive, right? Oh, which is negative. Yeah, that works, right? Because I want it to be less than 0, or less than or equal to 0. And then if I plug in 7, I get positive, positive, everything's positive. That's not less than or equal to 0, so it's that. So what we have here is that this inequality will be true anytime you're over here forever, or between here and here. So my answer, final answer to this is negative infinity to 0. Do I include 0 or not? Do I include 0 or not? Can you plug 0 into this? No, you'll get division by 0, right? So you are not going to include 0. Union, now everything between 2 and 6. Everything between 2 and 6. Can I include 2? No, right? I can't plug 2 into this. I'll get division by 0. How about 6 though? 6, yes, because 6 can go in here. And if I plug in 6, I will get 0, which is okay. I want it to be less than 0, less than or equal to 0. So I put a bracket there. There it is. All right. That's a messy problem. There's a lot going on there that you need to understand. So, yeah. Okay, find the inverse of a function. So this is a very systematic way process. You're going to rewrite the function. You're going to replace f of x with y. Now, everywhere you see y, you put x. Everywhere you see x, you put y. Now you solve for y. So you've got to get y by itself now. So I would probably multiply both sides by y minus 5. I probably would. I would. Okay. I'm going to do that to clear the fraction. I'm going to distribute my x through. So I get xy minus 5x equals, the only thing left on the right side is 2y plus 1. And now I'm going to get everything that has a y on the left, everything that doesn't have a y on the right. So I'll have xy minus 2y equals 5x plus 1, which is moving things around left and right. The whole idea there was that I could factor y out of the left. And once I factor that y out of the left, I can divide both sides by x minus 2. Yeah, that's it. And then what I do is I call this the inverse function. Okay, that's your inverse. That one's not so bad, right? Compared to like the previous one. So that was 6 and 7. How are we doing on time? Okay. Find the domain of this function. This is another quadratic inequality. See, because we have a natural log. And what we should know in this class and moving ahead is that when you have a natural log, what you plug into it has to be positive. In other words, this right here must be strictly greater than 0. And guess what, everyone? That's another quadratic inequality. We just did a problem like this a minute ago, right? Quadratic inequality. So the first step is to set it equal to 0. I can factor this. I can pull out a 2x from both of these. So this is just a GCF problem. I don't even have to, there's no synthetic division or anything crazy. It's just GCF. Set each of these equal to 0. You get 0 as one answer, and the other answer is 1/4. So those are your two solutions. I put those on a number line. And I'm just going to mention right now, I am not allowed to plug those numbers in. And the reason those can't go in is because if I plug in 0 or 1/4, I get 0, right? Equals 0. That's what makes it equal 0. And I want it strictly greater than. So I know that at the end, I'm not going to include these points, but I need to figure out if I include these regions or not. So we'll test -1. Oh, yuck, 1/8. And 1 maybe. And those are just going to get plugged in right here, and I'm going to see if it's true or false. So let's see, -1 in there. -1 will not work. 1/8 will work, and 1 won't work. I'm not showing that step, right, of me plugging the numbers in. But just remember, they're getting plugged into this, and I'm checking, is it bigger than 0 or not? So my answer for the domain is everything between 0 and 1/4, not including the endpoints. I'm not quite sure why I omitted this, other than the fact that we didn't do a ton of this. But I'm just going to show you, I'm going to show you how this is done, because in my Cal 1 class, they have to be able to do this. So there were properties of logs that we had that I can use here. Basically, I have log of something divided by something. Two things divided inside of a log. So there is a property of logs that says when you have division inside of a log, you can split that into 2 logs with subtraction between them. I'm just showing this to you because I feel incomplete if I don't. All right, so I split 1 log into 2 logs using properties. There was a bunch of properties of logs I gave you. Remember, there's like a big list of them. This is one of the properties. Do y'all want me to go look it up, or you trust that you could find it? What do you want? Look it up or no? No? All right, now once I've split this into 2, I noticed that on the first log, I have multiplication here and I have a multiplication there. And that means I can split those into 2 logs. So this becomes log base 7 of x and plus log base 7 of the square root of x plus 1. Then minus over here, this will get split into 2 logs, log base 7 of 49 plus log base 7 of x minus 4 to the 5th. I put this all in brackets because this minus sign is going to be applied to this log. And if I split that log into 2, the minus has to go to both. Next thing I'm going to do is I'm going to realize that the square root really means the 1/2 power. And the reason I'm doing that is because everywhere I see a power, powers can come out in front of logs. So that 5 can come out like this. So we have log base 7x plus 1/2 of log base 7 of x plus 1 minus log base 7 of 49. Hey, wait a minute. Log base 7 of 49, that's just 2. That's just 2. Why? Well, because this is saying 7 to what power is 49? That's really what this expression means. 7 raised to what power gives you 49? Well, 7 squared. And then distribute the negative here, -5 log base 7 x minus 4, period. We're done. I just wanted to show you that's what it means to expand it. If I ask you this on the test, it'll be a bonus question, all right? I'm moving on. This is basically the same thing, opposite direction. You have a bunch of logs and you can put them into 1 log. Ooh, solving an equation where your x is up here. We did these. This is the last exam. So I have to realize that this is 5 squared to the x minus 7 times 5 to the x minus 8 equals 0. I'm going to bring that 8 over to the left-hand side. And the reason I brought it to the left-hand side is because I'm recognizing here that 5 squared to the x is the same as 5 to the x squared. These are identical. And so this looks a lot like a quadratic. I'm going to make a substitution. Everywhere I see 5 raised to the x, I'm going to replace it with u. So this becomes u squared minus 7u minus 8 equals 0, which factors u minus 8, u plus 1 equals 0. Then solve each of those. U is 8, u is -1. And then replace u with what it was. So this is 5 to the x is 8, and 5 to the x is -1. The second one has no solution because you cannot raise 5 to any number and get a negative number. On the left-hand side, I'm going to use the log. I'm going to do natural log of 5 to the x on the left, natural log of 8 on the right. That allows me to drop the x out front. X times natural log 5 equals natural log 8. And then I divide both sides by natural log of 5. And then I need my calculator for that to get a decimal answer. Natural log 8 divided by natural log 5. 1.29 approximately. 292. All right. Does that look familiar? And that was exam 3, if I'm not mistaken. Exam 3, right here. Number 9 on exam 3 was like that. Actually, yeah, number 9A was like that. All right. That was 11. Let's see, 12. I'm not doing the half-life. Solve the system of equations. Wow, are we almost done? We're almost done with this. Okay. So solving a system of equations, this is 2 equations, 2 unknowns. So you're going to use either substitution or elimination. I'm going to do elimination. I'm going to choose to do elimination. I'm going to kill off the x's. So I have to multiply the top equation by 2 and the bottom equation by -3. And what that will do is that'll turn this first one into a 6x and the bottom one into a -6x, and that'll make them cancel. But I have to distribute that through here and this through here. So I have my new system, 6x plus 8y equals 22. And then I have -6x plus 15y, careful with your signs, equals 24. And now I can add these down. So when I add down, I get nothing. And then here I get what? 23y equals 46. Oh, isn't that nice? Divide both sides by 23. And you get y is 2. Once you know what y is, you can pick any equation you want. So I'm going to pick this first one right there. I'm going to write that equation down. And I'm going to replace the y with 2. So 3x plus 8 is 11. So 3x is 3, yeah. So x is 1. So your solution is the point 1, 2. You can write it as a point, or you can just box it up. X is 1 and x is, or y is 2. That'd be fine. Just remember visually, what we've done is we've found the intersection of 2 lines, right? That's what we've done. Questions? Okay, let's do something. We still have time, but what I'd like to do here is offer you a little bonus right now. Okay, something fun for you, I guess. I want to see if you can solve this system. All right. And when you after you solve it, okay, you're going to send me the solution in the chat. What's X, what's Y, what's Z? Just chat to me what X and Y, X, Y, and Z are. All right. Where's my chat? All right. If you don't want to do this, you don't have to do this. All right. But I'm offering this as a bonus right now. I will apply the bonus to the final. It's not going to be a huge bonus, so just a little something for you. But I want to see if you can solve this. For those of you who have your calculators, you can check, but I want to make sure you can do it by hand, because on the test, you're going to have the work showing it by hand. So this is probably going to take you about, I don't know, 5-10 minutes. Why don't you take some time to see if you can solve this? And just for fun, I'm going to put you all in breakout rooms. I don't mind if you all talk to each other to help each other out on this. All right. Feel free to join. If you don't want to join, you don't have to. We're just going to go another minute or two. Okay, sorry about that delay. Okay, everybody who wants the bonus has sent me their solution, yes? Okay, I'm gonna go off of that then for the chat. All right, there we go. So let me show you, let me just show you how I did it real quick. So what I did was first got rid of the x's, so I multiplied by -2 across the top. Got that, added the first two rows together, replaced the second row with that answer. Then I tried to get rid of the x here, so I multiplied top row by 3. That got rid of, well, that will allow me to get rid of these x's, so I multiply through by 3. I add the first and third rows together, replace the third row with that answer. Get this. Then I try and get the y's to go away, so I multiply the second equation by 4, the third equation by 5. That'll give me a 20y and a -20y. Go ahead and multiply that through, and then add the second and third equations together, replace the third equation with that answer, and get 15z equals 15. And then that'll allow me to solve for z. Z is 1. Once I have z, I go back to the second equation, I get y. Y is -1. Once I have x, z and y, go back to the first equation and I get x. So 2, -1, 1, which looks like that's what everyone got that sent me something. So good. All right. Any questions there? Okay, so that completes the review. Now, the last thing I want to do here is just go back and look at the exams. Here's our exam 3. I just want to kind of highlight the things that I think I would be like, if I were you, what I would be looking at to review. I'll narrow it down for you a little bit. I probably won't ask you, I'm going to go backwards, starting with exam 3. I probably won't ask you to graph an inverse. I'm going to highlight here this because I actually asked you that on the review. So I would definitely be interested in that. Solving these log equations, right? Solving these log equations, I would definitely make sure you're clear and comfortable on those. It's pretty much all of these log and exponential equations. The bacteria, that was a pretty straightforward problem. Most of you did well on that. So, you know, make sure you know how to do that. So that's a lot from the second one, I mean, from the third one. Let's see, the second one. Graphing a quadratic, well, that was on the review. Graphing a polynomial. Here was one where it was already factored for you. I probably won't ask you that. It'll probably be more like that. And then the rational function, like I told you, maybe this, but a very basic one. Maybe. Solving the inequalities. We had one of those on the review. Was that it? That's all of exam 2. Exam 1. Okay, there's a lot here. Oh, this is already highlighted. All right, I'll highlight in green instead. Let me see. Solving a quadratic, a radical equation. Domains, we kind of already went through that in the review. Difference quotient, right? This was, we just did one of these on the review. Probably won't ask you to graph a piecewise function. That's pretty much it. I mean, that's what I would focus my attention on. Okay. And by the way, I'm showing you exam 1 review. Do you want me to look at exam 1, the actual exam? Yeah, so things like solving this, domain, difference quotients, this graph, no. Transformation, probably not. Exam 2, yeah, we did exam 2. Yeah. All right, any questions? We only have 10 minutes, so really, I mean, it comes down to you just putting in the time to review and study and come prepared, hopefully, on Wednesday. Or wait, yeah, Wednesday, right? That's what we said, Wednesday. So if there's nothing else, you're free to go. I've got nothing here for you.
Is this gonna be posted on the YouTube, your YouTube channel?
The video of today will be posted in YouTube as usual, and then the notes as well. So what I wrote down today, let me see, where is it? Is this it? Yeah, I'm going to rename this solutions. Oops, solution. I'm posting this, right? What we did today, I'm going to post that in our notes for the day. Right here. There we go. It's posted. So a PDF copy of all my work here is posted, and then the video will be posted later today.
Thank you.
Okay. So study hard. Remember, your final exam grade will replace your lowest exam grade. 5-point bonus for for me working out. So, all right. Okay, thank you all for your attention and participation. Really do appreciate it, especially the people who had their cameras on most of the semester. You are going to get bonus for that. I've been keeping record of that. I know who you are. So, all right. Okay, everyone, have a great day. Good luck
Thank you.
studying for your other finals as well. Good luck on those.
Thank you, sir. Have a good one.
See you Wednesday.
Thank you,
Professor.
Professor.
Have a
Have a
good
good one. See you
You too.
Wednesday.